So first of all, I want to say welcome to each of you that have joined us tonight. It's going to be a very exciting presentation. We are here to welcome Trevor Graff, who is the Chief Scientist for the Jacobs Science Department as part of the Astromaterials Research and Exploration Science, which is the Ares division at the NASA Johnson Space Center in Houston, Texas. He is the project manager of the Exploration Science Group, coordinating the tools, the techniques, technologies, and training required for the exploration, and is lab manager of the Spectroscopy and Magnetics Lab, conducting detailed analysis of astromaterials and Mars analog samples. Trevor has been involved with numerous NASA missions, including Mars missions, analog missions, and preparing for the Artemis lunar exploration. Please join me in welcoming Trevor Graff.
Thanks, Margaret, and thanks to you and your team, and really excited to share some of the things of the upcoming landing on Mars with you guys today. I've been thinking about Mars for a long time, as you can kind of see on this first slide. I've been thinking about Mars since the early 2000s, when I had this unique opportunity down here to start with an orbiter around Mars, and have been participating in Mars missions ever since. So participated in the Mars rovers that we'll talk a little bit, Spirit and Opportunity, Mars Science Laboratory that's currently on Mars operating today. And then what we'll talk about mostly today is the Mars 2020 rover mission and some of the unique aspects of that rover and some of the hardware that I was able to get on that rover. And it's really been unique to work at JSC and with the Mars community in many different aspects. And all that information and knowledge is now being applied to what Margaret said, and that's the Artemis mission. So a lot of what I would think about today is applying our knowledge towards going back to the moon and sending the first woman and next man to the lunar surface. Real quick, before I turn my camera off, I just want to again thank you guys all for your participation, and just point out that this picture in the upper right-hand corner, or sorry, left-hand corner, is during one of these analog missions where we go and we explore different extreme environments around the world on Earth in order to best prepare ourselves for going to places like Mars or the moon. So I got a unique opportunity back in a few years ago to live on the ocean floor. And so this is a picture of me living on the ocean floor with the habitat behind me, where we lived for 2 weeks inside this habitat on the bottom of the ocean seafloor, and went out and explored it like we would on the lunar or Mars surface. So a little bit of explanation on what that picture is all about. All right, so Mars Perseverance. I said we we're going to talk a lot about the Mars Rover 2020 mission. And I'm going to go ahead and turn my camera off there so you can hopefully see my screen really nicely. And so we're going to explore a little bit today about the rover, talk about the components of that rover, kind of the pieces, parts that make up it, the instruments, and the wheels and everything that makes up that rover, so you guys can get smart about what this rover is going to do once it hits the surface of Mars. We'll talk about the mission goals a little bit, of what its tasks are in front of it. And then if you missed the launch of this rover back in summer time frame of 2020, I'm going to replay the video of that launch for you so you can relive that and prepare yourself for, in 6 days and 20 hours, this rover is going to land on the surface of Mars. And so we're going to prepare you for what to expect on landing day here coming up in 6 days on February 18th, 2021. And so you'll be smart about this rover and all its capabilities, and can share with your family and friends what this rover can do and what it's about to do on the Mars surface. So let's start exploring. All right, so here's the rover. It's actually really big for a rover. It's 10 feet long. So if you can see my cursor in this direction, it's 10 feet long. It's 9 feet wide. It's 7 feet tall, so I'm 6 foot tall, and so this rover even would stand a foot above me. It has an arm on it, a robotic arm that stretches out up to 7 feet, and it kind of has like a hand on it. At the end of that arm, we call the turret, and there's a bunch of instruments on that turret, which I'll talk about here in a second. The whole thing, the whole package, just everything that's on this rover weighs over 2,000 pounds, so over a ton. And we're going to land this on Mars in 6 days and 20 hours. And you might say, hey, that kind of looks familiar, right? And so I kind of showed you on my first slide, yeah, we sent a rover similar to this called Curiosity back in 2012. And so we're using that same technology, kind of the same rover makeup with the mast and the 6-wheel drive and the radio, its power source and its communication. We're utilizing that technology of getting a rover like this to the surface, but now we're bringing on a whole bunch of new capability, new instruments and new capability that this next rover, Perseverance, is going to do and conduct on the Mars surface here in 6 days. And if you remember, just for scale, here's that Spirit and Opportunity rovers that I told you that I worked on. They landed in 2004. So these are about the size of a golf cart. And this one, Sojourner rover, landed in 1997. That's about the size of a microwave. And so now you can see the size of the rover that's going to land, just like Curiosity did, is almost the size of a small car. And the wheels keep getting bigger and bigger and bigger. So the wheels on the Curiosity rover and the Mars 2020 Perseverance rover are almost 21 inches tall, so almost 2 feet tall on these wheels. So it kind of gives you a size and scale of how big these rovers are. The rover has 23 cameras on it. And so, like your cell phone camera might have 2 or 3 cameras on your cell phone. The rover has 23 cameras. It has engineering cameras to help it drive. So like these front hazardous cameras and cameras up here to look at the surrounding areas around it as it drives across Mars. It has specific science cameras to go out and look at the surrounding of Mars in different wavelengths and different ways to look at Mars with some of the cameras that are pointed out here, both on its arm or that hand that I talked about and up on its mask. And then it also has entry, descent, and landing cameras. So what does that mean? So as it's going through the Mars atmosphere here in a few days, it's got cameras that helps it land where exactly we want it to land. And it's also going to be taking pictures on its way down to share with people and it's sharing that experience of its landing on the Mars surface. It has 7 main instruments, right? So I said, the rover's kind of the same, but what's different are these 7 instruments. These are all new instruments to go to the surface, and it brings on a lot of capability. So let me start back here and explain a little bit about these instruments. One is a subsurface radar. What does that mean? Well, it's an instrument in the back of the rover that looks down through the surface using radar to look down a few meters into the surface and look for water or water ice or different subsurface structure. So a really cool instrument that's going to help us understand the subsurface or below the ground on Mars. It has an instrument that's going to produce oxygen or demonstrate producing oxygen from the Mars atmosphere. And so that's a really cool technology that we're going to demonstrate with this rover. It has a bunch of instruments on this mast, right? So this is kind of the head of the rover that sticks up. It has an instrument called Mastcam Z, where it's a zoomable cameras. So these cameras are for science to look at the surface and off in the distance of Mars to explore. And then it's got this laser system called SuperCam that shoots a laser out of 7 meters or so from the rover and superheats the rock and looks at how that rock and the plasma that's formed in order to tell its chemical composition. So a really cool instrument for zapping rocks with a laser and telling its composition from it. It's also got a weather station, so it can tell the temperature and humidity and wind speed and things. So it's got a weather station called META. It's got an X-ray spectrometer out on the rover arm or the hand. And then it's got this instrument that's a UV spectrometer called Sherlock that, if you allow me to talk a little bit about Sherlock, because it's one of my favorite instruments. And it's part of that thing that I got to participate to send the very first piece of hardware that I got to participate and put my hands on for sending to Mars. And so here's a little bit more about Sherlock. It's a complicated instrument. It looks in the UV, like I said. It has 3 components. The first component is kind of what I think of as the brains of the instrument. So kind of like the computer and the electronics that are tucked away and kept warm inside the rover. It has kind of the part of the instrument that reaches out and touches Mars and to look at in this UV spectrometer. So that's out on that rover hand. And then this is the part of the rover that I helped build called the Sherlock Calibration Target. So this calibration target sits on the front of the rover so that after the rover, as it's in deep space right now, as we talk today, and as it lands at 6 days, it's going to be shaken and gone through all kinds of dynamics and thermal swings and things like that. And so that to calibrate that Sherlock instrument that's out here on the end of the arm, we're taking some known calibration targets. And so they're about the size of a quarter, and there's 10 different targets on this calibration target that I helped build that we're taking to Mars, and it has some really cool targets that are on there. Overall, this thing is about the size of your cell phone, a little bit longer, maybe a little bit thicker, but it sits on the front of the rover. And I talked about those unique aspects of this calibration target. I'm going to specifically talk about a few of them and highlight them for you. So whenever you see the pictures coming back from Mars and you see pictures of this cal target, you can be like, hey, I know what that is. And so first thing I'm going to talk about is suit fabrics. So with my connection to JSC and the work that I'm doing currently for the new spacesuit and thinking about going back to the moon, we were able to make a connection at JSC and send some spacesuit materials. So all these 5 targets that are on the bottom of the cal target are pieces of the new spacesuit that we're going to first send to Mars, and we're going to look and see how they degrade it on the Martian surface. So, if you're exposed, or like if you put material out on the Martian surface, it's going to slowly degrade over time because of the UV and the harshness of, some of the things in the Mars soils. And so we're going to take a look and see how those things degrade. And that's all part of the cal target and all part of that Sherlock instrument that can help us learn. There's actually a piece of the visor material, so we can see if the visor material yellows over time. And so it's this really cool way the rover can help inform the exploration of humans to come of the surface. And then the other piece that I'll talk about is a piece that's right here. Hopefully you can see my cursor. This is a Mars meteorite. So what are we doing here? We're sending a piece of Mars back to Mars. So this piece of Mars is a rock, right? And here I'm going to show a quick video of how we got this rock into shape to put on this cal target. It took many, many hours to use this saw that actually cuts a slice of that quarter-sized target, if you remember. So this slice through kind of like a piece of bread and popped off one of these slices of Mars to send back to the surface. And so this is the story of that meteorite. And so let me walk you through here. So the meteorite is called Sau08. It has a special name of where it was picked up. So we know it was blasted off the surface of Mars sometime in, past history. So there was an impact crater on Mars that flung this rocky material out into space. So we know that this rock, was flung through space, landed on Earth, just happened to hit the planet next to it, landed on Earth, and was found in the Oman Desert in 1999. So somebody picked it up in the Oman Desert. It found its way back to the Natural History Museum in London. So this is we're following along the path of this rock. It found its way to JSC, where we sliced and diced it, like I just showed you on that video. We added it to the cal target and delivered that cal target to JPL, where they attached it to the rover. And I'll show you some images of that here shortly. Then they took the rover, sent that to the Kennedy Space Center in Florida, and I'll show you that with the launch and landing videos. We launched it. So this is where that rock is today, right? It's in deep space, 6 days away from Mars, closing in on Mars, and about to land in a place where I'll talk to you a little bit more about where the rover is landing with that piece of meteorite on it. So this is kind of its travel log from Mars all the way back to Mars. It's kind of a unique story and the first of a kind to send a piece of Mars meteorite back to Mars. Here's kind of just some fun photos of, this is myself and my build team of putting this cal target together, how to do it in a very clean environment. And so there's kind of a picture of those spacesuit materials now that I talked about. And there's that Mars meteorite that we're sending back. And here it is attached to the rover. This is that elbow joint of that arm that's on the Mars rover. there's that Cal target sitting up front, kind of like a license plate on the front of the rover, so that it can come back and look at those targets over time and help calibrate that instrument that I talked about. One thing to keep an eye on, and I'll talk about here in a little bit, is you might have heard that this Mars rover has a helicopter on it, right? And so down here is the helicopter, and stay tuned for that. I'll tell you a little bit more about that here in a few minutes. All right, so here's the Cal target. See that little red thing? It now has a cover plate on it, so it's covering up the targets to keep it clean. And now you see it attached to the rover. And so this picture also gives you a kind of a scale for how big this rover is. There's a technician sitting underneath the rover. Here's that robotic arm. Look how complicated it is with the wires and the motors and the wheels. It's an incredible machine, and I was really proud to get the Cal target on there and all its functionality. So thanks for listening to my story on how I get the Cal target there. But here's another example. There you see the Cal target. This is the first time the rover stood up. And so they're putting weight on the rover wheels. Now you're kind of, getting your eye trained to where that Cal target is, where the rover arm is. You guys are getting smart about what this rover is. And look, there's that helicopter I talked about, and I'll show you a video of that here soon. The rover does also some other things. So we talked about those 7 instruments. We talked about all those cameras. It also has a drill on it. So what's the purpose of that drill? Well, it's to capture some and collect some rocks on Mars that we can eventually bring back to Earth. So here's that drill that I'm circling with my cursor now. And the next thing I'm going to show you is a video of how that drill works. And so ultimately, we're going to try to drill up to 40 some samples of Mars, contain it. And so in this next video, you'll kind of see that, and I'll walk you through it. So let me start and jump ahead a little bit here. So here we see the rover on Mars. We see that arm being deployed with that turret hand, or that arm, with the drill on it and a few instruments. It's going to go out and put that arm against a rock that the science team decides that they want to collect. And then it's going to drill down into that rock and collect that material to be able to store and hopefully bring back to Earth one day, so we can look at it really in detail in some of the labs on Earth. So it comes back and it delivers that to this special place on the rover that can store that sample. And then, surprise, there's a second robotic arm that you really can't see unless you look underneath the rover that actually helps process all those samples. So here it's taking that sample that it just drilled, and it's going to store it. And it's going to do that hopefully up to 40 times on different rocks across the Mars surface, so that we can eventually help bring those things back and study them more in the labs like I talked about here on Earth. So here's the key sampling things that it will do for each one of those targets. Incredible technology, and kind of the hidden gem, that robotic arm and storing all those samples. Okay, now I don't want to forget the helicopter, because everybody asks, God, there's a helicopter on Mars? And so this is a technology demonstration of how to do first flight on the Mars surface. And so there's a tiny little helicopter. It weighs 4 pounds. It's got a pretty big wingspan, or rotor span. So it's up to 4 feet rotor span. And these things spin incredibly fast. So because the Martian atmosphere is a little thinner than on Earth, you have to spin your propellers really, really fast in order to get flight. This is solar paneled, so you see a solar panel up there, so it charges after every flight. And it's got 2 cameras on it to take pictures of the surface of Mars as it flies along. So the next video you'll see is exactly what we hope to happen on Mars. Here's another picture of where that helicopter is located, at the belly of the rover. Here's another little look at the Cal target sitting there that I always like picking out the Cal target since I helped build it. And so now we're looking at the belly of the rover, and the next video here will show you the first flight that we hope to see on Mars soon after landing. So again, only 4 pounds. It's going to be dropped off from the belly of the rover, so it'll be just sitting there on the surface. The rover will drive a little distance away so that it can take those cameras that I talked about and look back at the rover. and it can fly up to 5 or 6 times. We're spinning these rotors really fast. We'll go up 5 to 7 meters above the surface, so tens of feet. You'll be able to watch this all from the rover. Then it'll fly across the surface and help take pictures. So it's kind of like a scout to help take pictures of what's in front of the rover. And so here you see it taking pictures that'll help the rover figure out where to drive next and where it help the science team explore the surface from this aerial view. So really cool technology, and everybody's looking forward to seeing the first flight on Mars. All right, so let's explore a little bit more about the mission goals, right? So we're sending this rover someplace unique on Mars that we haven't gone before, and I'll show a slide of that here in a second. But we're really looking for 4 things from this rover as far as its mission goals. One is to identify past environments that are capable of supporting life, right? And so we're going to an environment, in this case, what we think is an ancient lake, to help explore that lake and look for the environment that's capable of supporting life. Like lakes are really good past lakes to harbor life, and that's the reason why we're going to the landing site we are, which I'll show you here in a few slides. We're going to seek signs of possible microbial life. So even once we get there, we're going to say, okay, the environment looks good. Now can we find life? And then, like I showed you with the sampling system, that drill out on the rover arm, we're going to collect and core those rocks and soils so that we can eventually store them and bring them back to Earth where we can really explore them. And then there's all the things, so this is the 4th objective, is all the things to prepare for human exploration. So part of that's that MOXIE instrument that I talked about that's going to create oxygen from the Martian atmosphere. Part of that's the testing of spacesuit materials, like on my Cal Target, go my Cal Target. And then there's other things to help explore the surface with humans. So there's a lot of capability in this rover that will eventually lead to helping us explore the surface with human beings here soon. Okay, so where are we sending this rover, right? So we're going to go to look for this habitable environment. And so you see here, Mars 2020, that's our Perseverance rover, is going right here. And just for context, we talked about Spirit and Opportunity. Those are those 2 golf cart size rovers. We talked about Curiosity. That's kind of the Mars 2020 Perseverance, like big sister that went there in 2012. And then there's some other landers, and here's that Pathfinder, that one that's the size of a microwave. So this is like a squished view of the globe of Mars. And so the next slide I'm going to show you is a kind of a blow up of, or a highlight of this, where this white box is. And so now we've zoomed in, we've colored the terrain. So low areas are blue and high areas are red. And so that's an elevation or terrain. And we're going to go to a crater that you can just barely see here called Jezero Crater. And so Jezero Crater is on the edge of a much bigger crater called the Isidis Basin. So just for scale here, the Isidis Basin is almost 1,000 miles across. It's like the 3rd biggest crater on Mars that's visible. So this is a huge crater, and we're going to a tiny one called Jezero on the edge of the Isidis Basin. And so the next slide I'll show you is a kind of more zoomed in on this white box. But before I do that, I wanted to mention a few other cool places. And so just next to this is this place called Syrtis Major. That's a giant volcano on Mars. So you can kind of see the top of the volcano here and see I'm outlining the periphery of the volcano, or the extent of that volcano. So a really big volcano sitting next to a really big crater. And there's a lot of stress in the crust around here. So there's big cracks called nile fossae. And so it's a really neat place on Mars that we finally get to go. And so the next slide, like I said, we're going to be zooming in on this white box. So here's Jezero Crater. All right. So the last crater we were looking at was almost 1,000 miles across. Now Jezero Crater is only about 30 meters across, or sorry, 30 miles. So 1,000 miles. Now we're down to 30 miles. And where we're going to send that rover, right? We've been talking about the Mars 2020 Perseverance rover. We're going to send it right here. Okay, so why send it right there? And it's going to target this almost 5-mile little spot. So all the way from Earth across deep space, all the way to Mars. And we're going to target the land right here, 5-mile little circle on Mars. Well, this is a really neat place. And so there's a blow up image on the right-hand side of your screen that you kind of see over here. So if I'm pointing out a crater over on the left, this is the same crater over here on the right. And you can kind of see this feature I'm outlining with my cursor and then outlining it over to the right. This is a delta, or what we think is a delta on Mars. And so what's a delta? So we have this ancient river that's coming in here and spilling out into an ancient lake. And so when that happens, you get material that's brought in by that river that kind of gets spilled out into what geologists like me call a delta. And so that can be a really interesting environment to go look for life and habitable environment. So that's exactly why we're headed here. And everybody's really excited about landing, hopefully right around here, and then exploring the delta and heading up the hills. And so this is a slide that kind of helps tell that story. So right here, now we're an oblique view of the delta. So imagine yourself standing here looking this way. And so now we're on the ground, we're looking this way. And this is kind of the proposed rover track. So whenever this thing lands 6 days from now, it'll take some time to kind of get its, work out its arm and make sure everything's set and use the calibration target to make sure that things that didn't get jostled around and all these instruments are set. But if, a little bit after that time, it's going to start exploring. And so we've kind of mapped out where it's going to go or where we propose it's going to go. And so that's represented by the green line here. So we're going to explore this delta on Mars and then head up the hills up into that unique area that I talked about with the volcano and the Nile Fosse. And there's just all kinds of neat geology up in the hills too. So hopefully it gets that far. And this is going to take a long time, right? This takes a while to explore. This is a big area. It's still miles long. And so this is still a big area for the rover to go. And so this green line represents almost 2 Earth years or 1 Mars year. So like 680 some days of traversing across this and doing science. So really cool and really exciting stuff. All right, so this is what people think this area looked like back way earlier in time. And what I've been talking about, like an ancient lake, right? And so if you remember that channel or that river that I said comes into this big 30-mile across crater, it will eventually fill up with water and then spill out the other side. So that's what you're seeing here. And this is an artist's rendition of what might have happened earlier, way earlier in Mars history. And so that delta I've been talking about would be right here, right? But this is when it was full of water and why we're so excited to go to this location and look for life. Okay, so now I want to shift gears a little bit and let's start exploring what's going to happen with the landing coming up in 6 days, right? And so what I'm going to show you some things here is for context of some videos I'm going to show you. First, we're going to look at the launch, but then we're going to get to the landing. But we have to take a look so we know what's going on some of the components. And so we've been talking a lot about the rover. So I'm circling the rover here. So you see the rover with its wheels retracted. You see, you guys are now all smart about the helicopter that's on the belly of the rover. So there's the helicopter, there's that robotic arm. We've been talking all about the rover. Well, how do we get it there, right? And so to get the rover down on the surface of Mars, we put it on a descent stage. So kind of this is the rover's jetpack. And there's more cameras there, right? So we talked about there's 23 cameras. There's cameras all over the place. There's also microphones. I'll mention that in a little bit. And then we kind of take that stack, the descent, the rover and its jetpack, and we put it inside the heat shield and a back shell. So we kind of contain that all. And then we put on a cruise stage, and this is what's helping get the rover to where it needs to be today. So just keep these things in mind as we go through some of the next slides and videos, and I'll be talking about some of these things as they get peeled away, ultimately just leaving the rover left on the surface. Here's some pictures of how it got there, right? So you guys are now smart of like, take this and comprise this all down, collapse it, and you get this, right? So this is a real life photo of the rover inside the heat shield and the back shell with the cruise stage on being tested. That all had to be put on a truck to go from from the Jet Propulsion Laboratory in California where it was built. So on a truck that went onto a plane. And so that plane flew out to the Kennedy Space Center in Florida, where here's that stack. Now it's just facing upwards, where it was put inside the nose cone. So, and then you attach those rocket pieces. So here's the nose cone. You put the nose cone on the rocket pieces all the way. You stack that all up. You drive that out to the launch site where you see it sitting here. So the tiny little rover inside its heat shield and back shell is out here in the nose cone, ready to be launched to the surface of Mars. And like I said, this all was about in the summer of 2020. So yep, July 30th, 2020 was the launch. If you missed it, no biggie. Let's take a look at it and watch it again here live. So I will mostly let this play and I'll just talk a little bit through it to highlight some things. So let's watch launch again.
The Perseverance rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control, standing by for SRB burnout shortly. And we have successful separation of Mars 2020 with the Perseverance rover.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.
All right, so arriving there February 18th, you know, if you look at your calendars, that's not too far away. So let's look at an orbital view of where that rover is today. So, okay, so this is, let me walk you through this for a little bit. So here's where Earth was. So we're looking down on the solar system. Here's the sun, here's Earth, here's Mars. So when we launched back in that summer of 2020, Earth was here, Mars was here. And so this is how the orbital plane of the Earth, and the orange line is the orbital plane of Mars. And so this white line is the rover headed to Mars. So we kind of launched when we were close to Mars, and the rover caught up with Mars. And right now, today, it's sitting right about in here. So it's right about 6 days away. So we've, you know, the last 7 months it's been making this journey. So the Mars is here now, Earth is way ahead. So just an orbital view of how long that journey is and how long it took to get there. And the last thing I want to show is this video of the landing. And so we're going to take a look at what's going to happen in 6 days and 20 hours from now. And now you guys are smart on all the components, but I'll talk through some of that to highlight it. So here we go. We're going to see what happens 6 days from now as we land on Mars. So in deep space, the rover and that stack that we talked about is cruising along. And on February 18th, it'll be racing really close. Mars will get really close in its front windshield, so to speak. And here comes that heat shield that's facing us right there. And then it loses that cruise stage. So that's what enabled it to get all the way 7-month journey. That's the first thing to drop off. And it starts to correct itself and go through the Mars atmosphere where it heats up a little bit, but that's where that heat shield helps protect the rover. We'll be able to hear this with the microphones. We'll actually be able to hear the sound after it lands. We'll be able to hear all that stuff. For the first time, we'll be able to actually hear this noises. Using the parachute that comes out of that backstage to slow it down. It's taking pictures now of the surface to be able to help control itself into to pinpoint landing where right next to that delta. There goes the back shell. It doesn't need that anymore. Rover and its jetpack trying to point landing right next to that delta that I talked about. Slowly slowing itself down. Now it's going to retract out on a cable system that gets the rover to the surface away from its jetpack. As soon as the wheels touch, it lets it go. And then the rover's ready to explore. And so all those things we talked about, all those instruments will be put to their use. And out in front of it here, you see what that delta will look like and all the terrain in front of the rover to go explore and start answering some of those scientific questions that we have and using the incredible capability of the rover to explore the surface. So hopefully if that doesn't excite you, I don't know what will, because it's incredible to think that here we are sitting on Earth. We've launched this thing in the summer of 2020. It's headed there in 6 days, and it's going to start exploring that incredible new area on Mars with all its capabilities. And it blows my mind every time I see that video of that's possible, and it is possible because we've done it before, and I'm really looking forward to getting down on the surface again. Here's a little bit more information. If you want to follow, definitely do a internet search for Mars 2020. You'll get all this information off the main Mars 2020 website. But on Thursday, February 18th, 6 days from here, make sure that you tune into that live broadcast, and the wheels down on the rover will be down shortly, about an hour and 15 minutes after that broadcast starts, and we'll all start exploring Mars together. So I think with that, I am going to open it up back over to you, Margaret, and see if you guys have any questions.
Terrific. So first of all, I will tell you that I'm sure that we have a group of students watching that all had completed and participated in the Roads on Mars competition. And unfortunately, they had VIP invitations to the launch, and they were not able to go because of COVID. The second part of that is we have a group of students that were participating in the STEM Enhancement in Earth Science project that actually investigated Mars 2020 and participated in that opportunity. So I know that there will be several questions from those students that will celebrate the landing, and also thank you for the presentation. So first of all, I think we have a question in the chat about how will the cores be taken and returned to Earth and when?
Great question. Yeah, so those cores, they'll be collected over the 2-year lifetime of the Mars rover mission. Some of them might be dropped from the rover as it explores, and some might stay with the rover for future mission. So there'll be a collection rover. So another rover will have to go and collect some of those core systems that this rover collects, the Mars 2020 rover. And then there'll be another system that will have to launch those things off the surface of Mars. So the first launch from another planetary body. And then there's got to be another system that grabs that and brings it all the way back to our labs here on Earth. And so that whole campaign is called the Mars Sample Return, and that's being developed now. All the architecture, all the engineering, all the details that I just talked about, that's easy to say, but really hard in the engineering to do. All that's being worked out now. And so those, hopefully we get those 30 plus, almost 40 cores back on Earth. And the time frame of that is in the 2030 time frame. So we got to put all the pieces in place now to make that happen, and hopefully get samples back in the 2030s.
Another question in the chat is, how fast does the rover actually move on its surface?
It moves kind of like a slow walking pace. It's, it's only a few miles an hour. It takes pictures as it goes, so it decides intelligently where to go. There's a rover planners that kind of give it the direction and distance of where they want it to go from day to day. And so it moves like a slow walking pace whenever it's cruising along the surface. This rover will actually go faster than any of the other ones we've sent there before, because we keep on putting intelligence in there so that it can make those decisions faster of whether to go to the left of the rock, big rock, or to the right of the big rock. And so once it starts cruising, it can go pretty quickly.
And can you explain how the microcopter was tested and designed to fly on Mars?
Yeah, a lot of testing on that. Not necessarily my expertise, but I've definitely seen, and know some of the people that worked on that project. They had to put it in a giant test chamber that brings it down to the Mars atmosphere, because like I talked, that thin atmosphere on Mars is a real challenge, because you have to spin the rotors faster and faster, or you have to have a super lightweight system. So in this case, they had to do both, right? To be able to fly on Mars, you had to have both a lightweight system and super fast rotors. And so that was all tested in some big vacuum chambers. And it's going to be really interesting to watch that fly, especially from the point of view of the rover, right? And so the very first flight, they're just going to hover maybe a few meters above the surface and then land and learn a lot from that. And then progressively, it's going to get more and more complicated, where the little helicopter can take off and move laterally to be able to take pictures and be kind of that scout that I talked about in front of the rover, taking pictures of its way ahead.
What happens to the jetpacks?
That gets it essentially crashes on Mars, and so it takes off and it tries to get as far away from the rover as possible, but it'll crash land on Mars, and it's a disposable piece that gets crash landed. Once it drops off the rover, it's kind of done its job, and so it tries to get as far away from the rover to preserve not damaging the rover.
And can you please explain how harsh the environment is on Mars and what has to be, what do they have to take into account when you're building a rover to navigate in that harsh environment?
Yeah, fantastic question. So a lot of temperature swings, right? Like Mars gets cold and warm. So you have to design your rover to be able to handle those temperature swings. It's also going to be a windy place, right? And that's been a benefit of other rovers that we've sent that have solar panels. This rover has a radioisotope generator, so it derives its energy in a different way than the solar panel rovers that we've sent before, like Spirit and Opportunity. But there's wind that you have to contend with, and that wind has actually helped, like I was saying, solar panel rovers, because the winds actually brush the dust off of the solar panels and given the rovers, much more power. The terrain can be really challenging. So we're driving over all this terrain. One of the things we learned from the Perseverance rover, that rover that's up there exploring right now and launched and landed in 2012, is the terrain really chewed up the tires, right? The tires took a real beating. And so we took that knowledge and built better tires. So the Mars 2020 Perseverance rover has a lot better tires to be able to handle rough terrain. So there's that's just an example of some of the challenges of the surface. But the good thing is that we're getting better and better at it. Ever since that small little microwave size rover, we're just learning more about the challenges of Mars and how to solve those, both engineeringly and in the science realm.
So the next question is kind of a two-part. So first of all, how long does it take to communicate from Earth to the rover? And then what type of processing power is needed on the rover to be able for it to be usable?
Yeah, so I showed that one graphic of like where Earth is now and where Mars will be when we land. And so as the planets get further apart, the time to communicate between planets, right, they call it the one-way light time, gets longer or shorter depending on how close the two planets are. It can take 7 or 8 minutes, and as long as like 20 minutes to communicate one way between Earth and Mars. And so that changes over that mission duration as the planets change in their orbital locations. You know, when Spirit and Opportunity, for example, when I work those missions, you know, it's interesting to work those because you would design your, you know, the commands that would go to the rover the next day, and think about that those commands get sent to the rover. The rover says, yep, I've got them, and sends a signal back before it starts working those. But to think about something that you built that gets sent and doesn't arrive there digitally for up to 20 minutes later is always a kind of a cool concept to think about, of how long it takes to send the ones and zeros, the digital information across space. And I think the second question was about processing power, like
Yes.
the computing power. That's always getting better. I don't know exactly the parameters of the smarts behind this rover as far as like its processing power. One of the challenges that, to the earlier question, is radiation hardening, right? So one of the challenges on Mars is there's a lot more radiation, and you experience that radiation out in the solar system once you get past the protective magnetosphere around Earth, like the protective bubble around Earth that we all have protecting us from solar radiation. So you have to have components that are radiation hardened, and so sometimes that limits the amount of smarts comparative to robotic systems that you might have here on Earth, because you have to specialize those systems for that extreme environment and radiation.
So based on the various landscapes on Mars, one particular question is about canyons. So did the science team select the location to land based on safety and traversing in that area and the science?
Yeah, engineering is always a part of, you know, and that's a fabulous question, because it's this part that I like exploring, is this engineering science trades, right? Like I'm a geologist, so I'm like a scientist at heart, but like working with the engineers, I've learned all the types of things that they worry about, right? Like landing safely. And then the science say, but I really want to land next to this delta as close as we can get so we can start exploring right away. But all those things are in the trade space, where you want to make sure that, you know, you don't have a mission unless you land successful. So the engineers say, hey, look, this is where we can go. And the scientists say, what about this? And then it's a trade space back and forth to ultimately arrive at the optimal solution that satisfies, you know, the mission goals and safety and all those types of things. So it's part of the things that I really like. The engineering side of me really likes to think about the things that they have to worry about as a scientist. And one of the things that's fun is getting them engaged in the science, right? So if you're an engineer working on the rover, and let's say you're a rover driver, or you built one of the pieces of instruments, they also really like knowing what it's going to do at the end of the day and being involved in the science. So I love that integration between engineering and science and technology and stuff like that. And so hopefully that answers the question.
So the question is, if they find life or signs of life, including water on Mars, what would be the next steps?
Well, we kind of already have that planned in, right? With the science or the sample return would be to bring those samples back to Earth, you know, and explore those safely in our labs here on Earth. And so if we find signs of life, you know, we can explore that with our instruments in detail and learn that as much as possible. But really, to start understanding Mars and the samples and its past history, we really want to get those samples back into the detailed labs here on Earth. And so that's already kind of built into the plan with that Mars sample return campaign. All those components of the bringing the samples back here are already being worked and thought about. So that would be the next step.
And how does that research affect our life here on Earth?
Oh, there's tons of research and tons of technology that we learned from these robotic missions here on Earth. The technology for the artificial intelligence that's, like I said, about the driving of this rover, all that stuff feeds back into pushing the technologies that we think about for improving our life here on Earth, right? And so, and understanding the science, so that's the technology side. There's a lot there, but on the science side, it's understanding our place in the solar system, right? Like we don't know how life really took hold, whether it was ancient, life from ancient, meteorite impacts and stuff like that, and that's all preserved on this nearby sister planet on Mars. And so studying that to understand how life took hold here on Earth, or did it, is Earth special, and that life only started here because of a unique circumstance. From a science standpoint, we're really interested in that to help us learn about ourselves and how Earth is unique or not unique in the solar system. So that's the part from a science side that I really am interested in.
And I think our last question, although we have several in the chat, but the question is, how long will the rovers be on Mars? And if someone wants schematics or additional information, where would they go to get that?
Sure, great question. So the primary mission of this rover is 687 days. So 1 Mars year from the entire circle around the Earth, which is about two Earth years. That's not saying that after 687 days, they turn a switch and turn the rover off if it's still operating. And that's been the case for a lot of these rovers we send to Mars. They're still operational after their primary mission lifetime. And so they keep on exploring, right? Like we have the team that keeps on sending it commands, and there's always more and exciting science to do. Like that green line that I showed, somebody probably could have drawn that green line 3 times as long to other scientifically interesting targets. So we hope this rover lasts its primary mission for sure, and then we hope it lasts 3, 4, 5 times as long, similar to some of the other rovers that have landed on Mars and done similar things. And it's all a testament to the teams that you saw, the pictures of the engineers and the operations people that work on these things. As for the question for more information, go do a internet search for Mars 2020. You should be able to get to the JPL page right as one of the first clicks. There is a ton of information there. All the videos I showed are there and available. There's even more pictures that you can explore. There's 3D interactive interactive components of like exploring the rover. So you can spin the rover in 3D and explore more about those instruments I talked about. There's more information about landing. So all the links you need for the landing on Thursday on February 18th are there. So you just have to go to that website and click on the live link. There's a ton of other STEM content, so other activities you can do. So that is kind of the portal to all the other information. And so I just encourage people to search Mars 2020 and go to that main NASA site, and all the information you need there is really a ton of information and a ton more stuff to dig into. I just kind of glossed over the surface of some of these things. And so if you're really interested in exploring more, I encourage people to look into that website, reach out to other people that may know more details about the stuff they're interested in.
So I know that I have learned a lot, and I appreciate Trevor taking the time to speak with us. I know this is a real critical and exciting time for you to have an experiment that you actually built, and it's getting ready to land. So fingers crossed, everything goes safely with the landing. And if you have any additional questions, please pop those in the chat now and we'll collect those. So this is Margaret Baggio. I'm the program manager for education and outreach for NASA's Texas Space Grant Consortium and the STEM Enhancement in Earth Science, SEA's high school intern program. So joining me is Chris Wallish and Mary, both from the Washington Space Grant and NESSP. And we want to thank all of you for joining us tonight. It's been very exciting. So please join me in saying thank you to Trevor. You're getting lots of kudos in the chat box. Yay.
Thank you, everybody. Thanks for your interest, and go Perseverance on February 18th.
That's right. Okay, sounds great. Thank you all for joining us tonight.